Folks, will start today with this is the thing on Hibernate. Uh, it's a ORM framework, which essentially means it's an object relational mapping framework. Okay, so typically, and what we use till now are JDBC statements, Java database connectivity statements. But the thing is that it works fine. I mean, there's nothing wrong with it. But think from the developer's perspective and think from a large scale application. Now, if you have a database and there are multiple related tables, now if you have to write different kinds of features, you have to think about all the queries, all the elements which you're going to select, whatever will go in the where clause, and then formulate it properly. Now, sometimes this can go like, say, I can spend an entire page writing about that, okay, and the same query. This is going to create a lot of problems. Problems in the sense that it gives you a chance that because of all this stuff you introduce some errors, some small errors, okay, and this can get introduced into the code and you will be able to find this out in production environment. Sometimes in dev, but it wastes your time as such. Now, in most of the scenarios, we see that we have tables, right? And say the table is consumer address, maybe user table is there. For a batch, there is one batch process table. So we have several tables, etc., etc. The work which we do, and since we are using Java, and in fact, it's like there are only two types of languages. One is like procedural, one is object oriented, and most of the times there is object oriented. So in object oriented you deal with objects. So for every real time thing you have a representation. So if you are having a user in real time world, you are having a user here. If you are having a consumer, you are having a consumer here. If there is a bash process, you are having an object for bash process here. Now for everything you have one-to-one mapping, you have classes, okay, but you don't have anything of that sort with respect to database. So in database, even if the tables are batch, even if the table is consumer, you might not be exactly retrieving the consumer object, okay. So what you do is that maybe you just want the first name or maybe the consumer ID. What you just do is select consumer ID from consumer, where consumer name is equal to Abhishek and the username is equal to something. So you just give it a query, you retrieve some particular values, okay, or maybe not, you retrieve something else, but not exactly consumer object. So there is a disconnect there. I mean, you have to, half of the times you have to think about object oriented concepts, half of the time you have to think about writing queries, and then some time you have to spend mapping the results of those queries to the objects which you have. Now this results in a lot of boilerplate code. It's not very, what do you say, it's not the actual business. So the idea behind ORM framework is that you should be able to concentrate most of your times coding for the business logic, okay, and not writing the boilerplate code, okay. This was the first thing. Second thing was many Java developers or object oriented developers, I mean, the idea is they need not be aware or be expert in SQL. So as a developer myself, I can go ahead and write SQL queries, but I mean it's not required as such. I mean it's not recommended. It's not. It's, I should not do that because I'm not the expert in that field. I might be introducing errors. So there is something. If you use this object relational mapping in ORM framework, it gives you an option that, it will generate the code for you. So it is a framework where you did everything with respect to objects. So for consumer table you have a consumer object, for user table you have a user object, for bash process you have a bash process object. So you have everything represented in terms of objects and you just deal with objects, okay. So all your business processing etc is done with respect to objects, and whenever something needs to be saved in the DB, something needs to be retrieved from the DB, you click on, you execute some APIs and it gets done. So it should be as simple. And in the backend, there's some SQL queries which are getting generated by the framework itself. Okay, so this helps in many terms. It makes the coding easier. It makes onboarding of a new business feature easier. Developers need not worry about the SQL part. The queries which such ORM frameworks write, most of them, and I think you should be aware of it also, because database tables have primary keys. Okay, and most of the queries which these ORM frameworks write, they are on those primary keys. Okay, so in turn, these queries are most of the times uh, optimized optimized for giving you a good performance. If these queries, I mean the queries which are written on the basis of uh, primary key, that is not sufficient, then you have the option of writing the query yourself. And when you have to write the query yourself, you can do two things. One is that you can write normal SQL queries. Okay. Second thing is that instead of writing normal SQL queries, you can use a query language. So Hibernate provides you Hibernate query language. And so all, and it's not only with Hibernate, but all other frameworks such as say OpenJPA or Eclipse Link. So any of these ORM frameworks, they all provide some sort of query language. That is, you use the name of the classes which represent the tables. Okay, like say if you have consumer class which is representing the consumer table, then you can write a query just using the consumer class. So select start from consumer. Okay, where, and you can also give it alias. So select start from consumer C, where C dot first name is equal to something. So you can provide that data in form of uh, of a language which is similar to English language. Okay, so I mean, the using query language, uh, it's simpler as compared to uh, writing it properly in SQL syntax terms. Okay, so these are some of the things which Hibernate or any such ORF framework gives you, but we're dealing mostly with, I mean, Hibernate as such has become a de facto standard in the ORM world. So everywhere we go and you go for interviews and you ask folks, they're using Hibernate. So it's like, I mean, the big deal today. Anyways, I just this was introduction which I wanted to give you before I start with the actual course content, and many of the things which will be below will be related to what I've just discussed. So, anyways, I'll just pause for a moment and I'll check with you guys whether you understood or not. Guys, did you understand till now? Okay, thank you, Suhas. What about others? Aarti, Padmakar, Raghav, Reena. Did you guys understand what I was saying till now? So yes, from Padmakar's side. What about Aarti? Guys, I need answers fast. We need to proceed also, right? What about Raghav? Reena, you? Reena and Shravan, is it clear to you? Okay. So wherever it's not clear, just ping me. I mean, I can see your pings and I can respond accordingly. So, anyways, I'll move forward. So that is what will be discussed here. So again, to just give you a bit of a background, Hibernate was introduced by Gavin King. So Gavin King is one of the founders of Hibernate, and I was reading once that he is working on some project with Red Hat as of now. So I sometimes follow people who work on or who have introduced such big frameworks to see what they're doing. So that is just a bit of background, nothing important. Now coming to typical deductive problems. Now again, as I was saying, it leads to duplication of efforts in the same consumer table or the same consumer and address table. You have to filter data on different parameters. You again have to write similar queries. So your work is duplicated. Okay. And in the back end, like say one of my projects, they were using DB2 and they were migrating to Oracle. Okay. Uh, if you are using the queries, I mean the query structure, the parameters, sometimes the where clause, etc., will change a bit. Okay, but not in case of Hibernate. So in Hibernate, if you're working with objects, you still keep working with objects. Okay, so there are a few configuration files where you say that, okay boss, this is not a DB2 database, this is Oracle DB and this is the new user ID and password, and you're done. I mean, it takes care of it. So it is that simple. Now if you are writing queries, your code, your everything is tied very specifically to a particular database. Now if you are using any ORM framework, it decouples your database and your code, your application code. So and it helps to reduce effort if you're migrating. And I mean, it keeps an abstraction, layer of abstraction between what is there in the DB side and what is there on your side. So queries are tied to a specific database. As I was saying, developers have to write queries and thus need to understand SQL as well. Database generally has a relational view. I mean, you have like tables and which table is related to what, but code has an object-oriented perspective. So if you're using queries, you have to switch from one perspective to the other perspective. But if you're using Hibernate or any other ORF framework, you don't have to do that. Okay. So that's what I was mentioning here. So in the code, we need to fetch data from the DB and then convert it into objects. Or the alternative is to use a framework which lets you work using objects and internally generates the required queries. Since this requires mapping between database tables, because you have DB tables in the backend and you have objects. So there has to be some kind of mapping between tables and objects. Okay, and that's why such frameworks are called as object relational mapping frameworks. Okay, now Hibernate, again, as I was saying, it has become a de facto standard. It has like huge feature list. I mean, whatever you can think and you want it to support, it actually supports it. So you can go on their website and check. I mean, the feature list is actually very huge. Uh, I think in Java 5, I guess, Java came up with its own persistence API, 5 or 6. So the persistence API in the sense is that Java folks found out that it's better to standardize the way in which we access details from the database, because there are many ORM frameworks in the market and they all might follow different standards, different ways to retrieve data, and it might be difficult for you or for anyone else to have a common standard. So they defined a standard and they said that this is what Java Persistence API should support, and they also gave a default implementation. I mean, they gave not a default implementation, they gave the interfaces, etc. And there are other vendors such as Apache and others who actually implemented it. And since it was actually from the Java bucket itself, I mean, it got wider adoptance faster. So all the other ORM frameworks which were there in the market, they also started supporting it. So Hibernate also has support for this Java Persistence API. So it's nothing but it's a bunch of APIs following the Java Persistence standards, and we'll see later as to what I mean by that. But for now, let's understand that like many of the ORM frameworks, Hibernate also has implementation for the Java Persistence API. Now the thing is that we have to do the mapping, right? The mapping between the database table and the object. So how will you do that mapping? So the way to do that mapping, the way in which the entire industry started was use XML. Use XML to relate tables with the objects. Okay. Now the trend is going towards much simplification. So the development time is reduced. From developer's perspective, there is not much there's not much hassle. So what has been done now is that you use annotations. So using annotation like at, table, etc., you can just define in the class itself like what it should do and what entity it is, which table it is related to, and you need not define a separate mapping XML for this. Okay, so there are two ways. One is to define the mapping. The second way is to use annotations. And in today's class, like whatever course structure I have for today's class, we'll deal with both of them. Okay. So, in case of Hibernate or any ORM framework, like whenever you start it, I mean, and some of the SQL is generated depending on what you have put there. Okay, but like say if your specific queries, I mean, it gets generated at runtime also. At that time also, it finds the queries which it has to generate. So, and again, since there is a decoupling between the database and your application code, the same framework can be used. You need to change few properties. Okay, and the thing that Hibernate has not reinvented the wheel in the sense that every ORM framework uses JDBC API only, but it saves you from a lot of boilerplate code that you don't have to do it yourself. It's taking care of it in the backend from its own side. Okay. So the idea of ORM framework, as I was saying, is that you need not write queries. Okay, the framework will generate it for you. So, and even if you have to write queries, as I was saying, you can write in normal SQL also. But they like Hibernate also provides its HQL, Hibernate Query Language, and I mean this language uses object names which represent table names, as I explained earlier. So let's see one example also, and again, I mean, let's not get bogged down this example. This is just to give you a preview. Now we'll follow our course structure. If it is there, we'll also deal with such queries. If not, I mean, you'll have a reference. So, and anyways, for today's class, the idea is to get about the Hibernate overview, the difference, or you can say the relation between JDBC and Hibernate configurations. Okay, so just try to understand like how we do it. So if you see here, get user details. We're expecting a username, and this part we'll see. So let's not concentrate here. This is a piece where I want to show that how to use the Hibernate query language. Now, if you would have used SQL, you can see that this is not typically a SQL statement. You're using a from user u, and user is not a table, it is a class, which in Hibernate framework, if you have the mapping, this is related to your user table. Okay, so you're not exactly writing queries corresponding to your table, you're writing queries corresponding to the class which represents the table. And again, to give you a reference, in object relational mapping, that is ORM framework mapping world, the class which represents a particular table is called as an entity, entity. So all the classes which represent all the tables in the DB are called entities. Okay, so if you see here, this is a query which we have. Here we are setting the username, we are expecting a result, and that's the result we are returning back. Now this is a way to write the queries yourself if you are not satisfied with whatever Hibernate provides you out of the box, that is a query which it writes using the primary key of the tables involved in that particular API. Okay, so this is how you do it for what do you say this is how you write it for Hibernate query language. Alright, now let's go below. So is it clear till now? I'll just wait for 2 minutes and ask you guys, and I'll not go one by one. I just need yes, no, and depending on that I'll take it. Okay, what about others? Oh, good. Anyone with no? Okay, now again let's see on high level how the Hibernate architecture is. So this is how your Hibernate looks like. Yes, I'll be showing an example of XML and annotations both. So this is how the Hibernate architecture looks like. So So if you look at this, we have the database table, okay, and then you have all the low-level APIs. So in the backend, again, to reiterate, Hibernate has not reinvented the wheel, okay. It's the same thing. The only thing is that it's adding additional features. It's giving you a better way to access those APIs. You need not write boilerplate code or maybe framework level code yourself to access it. Okay, and let me give you an example. Say, and I might sound too old if I say this, but around 2005, I was working on an application. Okay, and that application, they had their own framework for getting all this data from the DB, and that framework actually converted the result from the database into the object structure. But they're not using Hibernate; they're using their own custom framework. Okay, so they had written the entire framework. Okay, and just to give you a reference of how that framework is to work, if you go home and try to do some reading about ORM frameworks, you'll find that Hibernate is there. There's one iBatis where you write queries, put it in an XML. So they were using these XML format, which is similar to what iBatis does today. And this entire work was done, and it's a proprietary work. It's not like open source, uh, by this client of mine. Now, and just to, this is only one client, right? This is one customer. This is one enterprise in the entire world. So it means, and and I think there are other people, there are other companies also outside who have done the same work again and again, again and again. So there is a lot of work which has gone duplicated, and if it would have been made public, right? If it had been made open source, it would have saved a lot of people's effort from long time back itself. Okay, so that is just one example I would just wanted to give you, that even if the ORF framework was not there, people were using it in one way or the other. Okay, so from my perspective, from the first day itself, I did not have to write the JDBC code myself, because wherever I went, some sort of framework was already there. Okay. Earlier also, today, it's a better structured one. You use Hibernate or any other API such as Java Persistence API. Okay. So let's look into these boxes. So you have the database, then you have the low-level APIs. You have JDBC, you have JTA, which is Java Transaction API. Then you have Java Naming Directory Interface, JNDI. So all these low-level APIs are there, and then Hibernate is sitting on top of it, and it uses these low-level APIs. Okay, so Hibernate has many classes as such, which are very core. You'll always see them getting used, and that's the reason I wanted to give a reference here, so that you have from beforehand some kind of reference of looking at it, and you understand the terms in a much better way. Okay, so the things which you have here is transaction factory. Okay, connection provider, session, transaction, session factory, persistent objects, transient objects, and this is application. So if you see, let's start from persistent objects. So if you see application and session, so persistent object is in between. So it is part of application, it is part of session. So you can understand that persistent object is part of both application and the particular session which is associated with the database. Okay, so the database has, your Hibernate framework has mapping files, right? It has mapping in the sense that this table relates to this class. So all these compiled mappings are represented by a class which is called a session factory. And from this session factory, every time you want to write queries or execute something, you can create a session. Okay, and once you create a session, you execute a select statement or insert statement or whatever, you create an object, right? Because it goes, fetches the details from the database and populates the corresponding object. So once you have this object, now this object also represents whatever is there in the DB, and Hibernate also maintains that information, that this is the object which I got from the DB. Okay, and application also uses it because you only queried for it. That's why it is maintained in between, showing that this particular object belongs to both application and session. So you can do changes to these persistent objects, and also, session.save, etc. you call, and it gets saved in the DB. You don't have to write or do anything else. Okay. So apart from persistent objects, you have transient objects. So transient object means that you have closed the session, but the object as such is there, right? So an object doesn't go by itself. So that object structure which is there, say if you have user object, it is still populated with all the corresponding or related elements, the related attributes. But it's not exactly representing a database now because you have closed the session. Now this object as such has no relation with the DB, but it is a useful object. It has all the related attributes set properly, and you can take it forward for executing your queries. Alright? You can take it for sorry, not for executing your queries, but for doing business logic in your code, but like wherever you can go ahead. So that's the use of transient objects. Okay. So persistent objects represent an object in the database. Transient objects used to represent an object in the database, but right now it is disconnected. That session has been closed. So it is just an object with related attributes set properly. Okay. So let's recap a bit. We have session factory which is here. Session factory represents a mapping which you have between the tables and between the classes. It's a compiled mapping, you can say, and whenever you want to execute some query, you create an instance of session from this session factory, and the session represents a conversation, an interaction between the database and the application. And because of this conversation or interaction, there are persistent objects which get created. During course of time, once you close the session, once you're done with writing the queries, the objects still remain. These objects can be of business value. You can use them for further executing some scenarios or for carrying forward and for future use cases in your application. Such objects are called as transient objects. Alright, so we discussed about session factory, session, persistent objects, transient objects. Okay. Now again coming back to connection provider. So connection provider is something which is not exposed to the developer as such, but if you want you can extend it. Again, it's the same. All the great frameworks, you'll find that they all follow design principles in a very very simple way. If you see their code, it's not that they have written something extraordinary out of blue and it was not thought of before, but the code is very very simple, and the design principles are also very very simple. So simplicity is the key everywhere. I just wanted to repeat, I said this beforehand also, so that you take care of it when you go in a production environment. But again, coming back to the topic here, so connection provider represents the connection. It is sort of what to say. Interaction between the Hibernate and the underlying low-level APIs. So if you have to get connection object, java.sql.connection, it is done through connection provider. Okay. So connection provider basically helps in getting all the connections. It is not open for you for modification as a developer, but you can obviously extend it and thereby add features on top of it. Alright. And then apart from these, you have transaction factory. So transaction factory is just a factory using which you can get a particular org.hibernate or transaction object, and this transaction object can be used to demarcate the transaction boundaries, saying from this place to this place this is one transaction. If something fails in between, Hibernate will roll the queries back for you. So that's how you mark your transactions, and from the DB perspective, it's very important to have those transaction boundaries set, and Hibernate provided a support from it from very starting, and Java Persistence API and other such APIs also provide support nowadays. So this is the overview of the Hibernate architecture. Are you guys clear with it till now?
How is transaction different from session?
Session just represents a conversation or interaction between a database and the application. So to understand that, a session can have many transactions in between. So, and plus in session you can execute many queries. So session is just a representation of the, what do you say, the interaction between the DB and the application. Once you have this session, say one time you want to go and start get the username, you can execute query for it. Okay. The next time if you want to get the consumer details, you can execute a different query. Next time you want to insert something for say a batch process, you can insert. So the same session object can be used to execute various queries, various different kinds of queries. But all these queries do not belong to one transaction, right? So transaction is per query, or like wherever you want to demarcate the transaction on that basis. All right, and the session is actually representing the entire conversation. So within that conversation, you can have many queries which are getting fired, which explicitly you are firing, and then using this transaction demarcation, you can have many transaction boundaries set within itself. So to say in very simple terms, a session can have many transactions. So did you understand it, Aarti? It was Aarti only, right?
Yeah, it is.
Yeah. Did you understand
I
it?
mean, I got the subset part, how transaction, there can be many transactions in a session. But how, what's the, I don't know how to put it. It's like when the session ends, starts and ends. Is it like when the DB is up
No,
from
sessions.
there?
See, yeah, I got a question. So, see, session is something which we start like as a user, as a developer from our side. So, session factory actually represents the mapping whichever is available. From the code, you have to start this session yourself. So, it doesn't start by itself. So, this session we have to create and start from the code. So, it is not
Yeah,
start.
means when the connection, does it mean when the connection, supposing there is a connection object or something?
Right. So the connection object is like abstracted by this connection provider. I mean, it is internal to this one. So whenever you create a session, I mean, like whenever you load the Hibernate application and you create a session. So whenever you create a session, internally it makes a call to connection provider. Connection provider makes a connection to the DB and gives a connection object back. So session actually wraps the connection object also. But the thing is that is not visible to you. So you from your side, you just open the session, you execute queries, you get the results, and you're done with it. But in the backend, you have connection object which is being created by this session, which we create ourselves. So session doesn't get created at the time of startup of the application. This is something which we do from our own side.
Okay.
Is it clear now?
Yeah.
Okay. Let me see. Others have also planned something. Yes, we can have multiple transactions for the same session, Shravan. So, once did you understand, or should I again explain? So, are you fine now with the question which you asked? Okay. Okay, thank you. So let me uh, go forward, and again I have put all the related elements here, which like what I was explaining. So one by one I will go through it, and again if you have any questions, you can stop me. Otherwise, at the end of this section, I will move forward to the next one because it was again related to the architecture stuff only, which we dealt right now. So the session factory, it's a compiled mapping for a single database, and we can get an instance of session org.hibernate.session using session factory. Okay. Now org.hibernate.session, it represents an interaction or conversation, as I said earlier, between the application and the persistent store. Persistent store is a fancy word for saying database. Okay. Now, as I was explaining to Aarti, so session wraps up JDBC connection, java.sql connection, and from here you can also get like say on the transactions. Okay. Now persistent objects are the objects which are associated with the session. They belong to both application and the session. But transient objects, they have been disassociated from the session. Now org.hibernate.connection provider is a factory for providing JDBC connections. Okay, uh, I mean, you need not worry about it in normal world. I mean, till now I have not seen applications where you actually need to go ahead and modify it. But Hibernate, I mean, gives an option. You can extend it and like improve the features. You can look into it and see what more you want. But normally, I mean, I have not found instances till now where you actually have to do that. Although you have this feature to extend it if required. And personally, I've never felt it. But again, I mean, there are thousands of things in the Hibernate API, and for any other API. So you just understand the concepts underlying, how to play around with it, and rest everything you have to explore as and when you get new requirements to work on. Okay, and again, transaction, as you I think already understand as well. So org.hibernate.transaction is used to specify atomic units of work. So this was again related to the architecture which we saw earlier. Let's move forward and go inside this basic Hibernate project setup. Okay, so the Hibernate, if you want to implement, there are two ways. One is the old way, and I still prefer it myself. But the second way is to use annotations. All right. So one is via Hibernate mapping XMLs, and the second is via annotations. And we'll see both of them. Okay. Now again, I mean, some things, and I want you to be very analytical. So that's why, like, even after going through a theory, you should be able to find out what needs to be done. So that's the kind of analysis skills you need to come up with, because there are so many technologies which are changing. Today you're reading Hibernate and they had using XML or annotations. Tomorrow they can have using something else. You never know. The pace at which technology is growing, it's not possible to be hands-on and practice for each and every small stuff. But if you have an analytical bend, you understand theory well. If you can read something and go ahead with it, you can pick up technologies like this. It's so easy, but you have to get that bend of mind. That's why whenever I'll deal with all these things, I'll also urge you to understand the concepts also in a better way, and look into other articles and related articles as well from your side. So a lot of reading is required as of now. Okay, so that is just to give you a heads up. Again, now if you come back and see, and I ask you that I have a database, I have a framework which represents the mapping between the tables and between the classes which are there in my application, and I need to write some query using this framework to get the data or to save the data. What needs to be done, right? So if you think what needs to be done, you need a database, you need an application having those classes. Apart from that, you need a mapping between the tables and the classes. So that mapping, let it get represented by an XML. So you need one XML which will have the mapping. Now all this database connection URL, user ID, password, you need one property or XML file for that. So you have one configuration file for that. So you have two, right? And third was you have classes, you have tables, so you have 4 things in total. What else? Now you need some kind of classes which lets you work with these mapping XMLs and the classes, and in backend it can run queries for you. So you need these these dealing classes as well, which helps you deal with underlying APIs of the framework. So these 5 things are required. Alright? And they are the 5 things which actually Hibernate uses. Nothing else is required. So if you apply a bit of a common sense, you'll understand the entire way in which the project should be written upfront. When nobody needs to tell you, I need not come and tell you. You can understand this from whatever is going on. Okay, so anyways, I'll move forward. I'm just trying to give you some sort of, like, you have to work on your analysis skills also, apart from technical skills, which this course will also give you regarding Java. So at the very base level, we need classes which represent tables. Alright, we need classes which deal with session factory and session Hibernate classes. Apart from that, we need mapping XMLs, the XMLs which map database table and the objects. Apart from the XML, we need some kind of configuration where we can define all the database properties. Alright. Now Hibernate has all of these, and using this piece, whatever I have defined here, there are elements and you can write your code using it. So first of all, you have hibernate.cfg.xml. This contains all the database related properties. So database URL, username, password, etc., etc. Everything is represented or it's there in this particular XML file. And again, all these things will deal in detail. Alright, so just see here and try to understand. Let's not go for every property by property basis, but on the whole you should understand what this is all about. Alright, so this is a hibernate.cfg.xml. Okay, starts with Hibernate configuration, ends with Hibernate configuration, and between you have this session factory representation, and you have various properties defined here. So which driver I should use, what should be my connection URL, what is my username and password, the connection provider, how many connection pool or number of connections you should maintain. Alright, when it executes queries in the log, whether it should show the SQL or not. Okay, which language is it. Okay, so all this information is defined here. Alright, apart from that, you also define the mapping table, mapping file name. The mapping file name meaning the file where you map the classes and the tables, that is also defined here. Okay, so this file we're going to see now. I'll show you. So this is, let me show you. I'll go down, so let's not get bogged down by me changing slides, because anyways I wanted to show you first. So this is a customer.hbeam.xml file. Alright, now if you see here, they have this entire mapping. So they have it starts with Hibernate mapping, ends with Hibernate mapping, and between you have all the mappings. So let's see one by one all the mappings. So the example which I have like shown here, it has customer table and it has customer underscore address table. So all the addresses which is there in the customer address belongs to a customer. So you have a customer and there are a set of addresses which are associated with that customer. In other words, a customer can have 0 or more addresses. So it can be 0 address, 0 is not possible, but still from mapping perspective it's possible. So that's how we say it. 0 address, 1 address, 2 address, 3 address, that is a possibility. So 0 to n you can say. Okay. So we have class, and the class name is cust. So this is our application class, cust. And if you would have noticed the class when I was scrolling down, this was this particular class, cust. But anyways, I'll show you once I go above, and show you. So you have cust class and table, which table it represents. So the first line itself defines everything. Okay, and then slowly all the attributes which are there in that class you map to the columns which are there in the DB. So the first column is ID, so you say which column it maps to. So it is cust ID, and again cust ID was a primary key, so it might be like it is assigned, you have to assign value to it. So the generator class is mentioned here as assigned. Alright, then you have fname attribute in the cust object, and for that also you have a column name fname in the customer table. Similarly for age, similarly for customer addresses. So customer address is cust, or the customer object will have a list of customer addresses. So that's how it is represented. And when Hibernate also has a support for your collection elements. Here we are using bag. The name is cust addresses. Then inverse is equal to true or false, that we can see later what it means. And then cascade all, and how it relates to. So key is cust ID. So what this means is that in the customer address table, you have a foreign key reference for the name is cust ID. Okay, and there is one-to-many association. So it means that this particular table customer has maybe many references, can have many references to customer underscore address table. Okay, and that is what is being represented by this mapping. Now, now coming back, so whenever you have one to many mapping, you have many to one mapping from the other side. So to explain you, like if a customer has many customer addresses, now if you think from the customer address perspective, one customer address can belong only to one customer. Okay, so if you have one to many mapping, from the other side there is many to one mapping. So if you see, let's come here and see about this class. So again, the name is cust address. The table is, ADDR. It can be customer address as well. It represents the same thing. Then you have the ID, which basically means the primary key of the table. Then you have address ID, and the column is ADDR underscore ID. Then you have the generator class, and then each attribute wise, address line 1, which column it stands for, we have defined. And since, as I said earlier, for every one to many mapping, we have many to one mapping. This many to one mapping is there with the class cust. Okay, and that is what we have mentioned here. And the fetch is mentioned as select, and the column is that cust ID is the column. That is how the two should be related. Now this is the entire h1.xml. So it's basically telling everything that how the relationship is between the two tables, and thereby telling how the relationship should be between the two classes which are associated. So I'll go up, don't get bogged down by me going up and down. This is just to show you. So coming back to cust, so it has all the attributes which are showing below, ID, F name, age, and if you notice here, it has list of customer addresses as well. And rest everything is, just pure getters and setters. And one thing more I wanted to say, discussed many persistent frameworks also force you, if you are like, if you're using it, and not like here, but maybe using annotations, you have to implement serializable as well. But that is not, I think, required for writing via XML, but that is also one of the requirements, I think, in Java Persistence API. Anyways, we'll see to it. So let's come below. And the next level is customer address. Again, this also, if you notice, apart from the ID, which is the address ID, the address line 1, the address line 2, we also have a reference to the customer table. So this reference means that if you are fetching details from the customer, you can also fetch details from the customer address. If you are fetching details from the customer address, you can also fetch results from the customer table. So this kind of relation, this kind of bi-relational mapping, exists. Now the idea is that if you see the cust table and had the reference of customer address, so if you execute a query, alright, so if you execute a query, then on customer table, so Hibernate frameworks tries to optimize, and it's not only the Hibernate, with every object-oriented mapping, object-relational mapping framework, ORM frameworks, they try to optimize the stuff for you. So the query by itself is not going to fetch all the customer addresses. Okay, so it doesn't execute that extra query to fetch the customer addresses. Only when you do customer.get customer addresses, it goes and fetches everything. So this join, wherever join is there, the relationship works in a lazy way. So only when it's required, it goes and fetch. Also, you can override this behavior. You can put the fetch as lazy, fetch as eager, but by default it is lazy. Alright, so this is what is out there. So now coming back to Hibernate util and Hibernate session factory. So in my example, what I've put here, these are the classes which will let you interact with the session factory and the session class which is there from the Hibernate side. So Hibernate util and Hibernate session factory is something which is there in our code, and we call session factory and session classes from here. So this is the Hibernate util class. Notice here we are, this is just say normal class. We are trying to get a session factory from here and return it back. So there's one class in Hibernate configuration.configure. It basically reads that XML file hibernate.cfg XML and by calling this dot build session factory, you can get the instance of session factory class, and you can return it, or you can have everything in one place itself, but since we can divide into multiple places as well. So that's how we create the session factory. Now if you see this Hibernate session factory class, it calls Hibernate util dot get session factory. So you have the session factory instance here. Now from the session factory instance, you're asking beforehand, right, about what session. So the session you have to create sf.open session, and that's when the connection is made to the DB. So you have the session which gets created. Okay, and since the session can have many transactions, you specifically have to open the transaction also, begin and end transaction. So the transaction boundaries has to be set from your side itself. So you see here we have session dot begin transaction, and then you have the relationship about customer addresses, customer, then you set whatever customer addresses dot set customer, or customer dot set customer addresses. So in both the places you have set the corresponding elements. So in customer you have set customer addresses, in customer addresses you have set the customer. And once you have done that, you're calling a method on session.save customer, and then you're doing a commit, and then you're closing. Alright, so your transaction is closed here. The saving part is done here, and here your session is closed. Once the session is closed, these objects, the cust object, and it becomes transient. Okay, just after this save was executed, till now it did not have any relationship with it was neither persistent nor transient till here. But once we executed session.save customer, it became persistent. Okay, and as soon as we closed, it became transient. So anyway, this is how we write a typical very simple application. All right, and a very simple application which uses Hibernate, and this was using XML. So if you run this main class, the data will get saved in the DB. Any questions till now? This was using XML. Guys, have any questions? Are you good? Did you understand what's going on? What about others? Is there anyone who did not understand? Yes, every table which you want to be used from the Hibernate side, you need mapping, and that mapping for every for every table there has to be a separate mapping XML file. Okay guys, so I assume that you are good. Let's move forward. For every table, yes, for every table you have the mapping here. Oh, for that XML file is not required.
Do you have
No, I'm sorry. You need to have mapping, but that mapping is required. It might not be in a separate XML file. You can define. Typically in various XML files, in one also you can define, but we go by relations normally. In the sense that whatever is related to customer, you can put it in one hbm.xml file. Whatever is related to bash process, you can put in another hbm.xml file. So that is just for logical grouping. But you can put all the XML files and all the related mapping in one file itself, as you have here for classes. So I'll change myself, Raghav. You have mapping. Mapping has to be there for all the XML files. The only thing is that, all the tables. The only thing is that it can be there in one XML file, or it can be there in different XML files. When all these things started, the idea was that for every mapping you have a different XML file. Okay, that's why if you see the typical mapping file name is table name .html. But you have the option, and since your schema can have hundreds of tables, you have the option of giving everything in one place. It's not going to stop you from doing anything. Okay, hope it's clear. Did you get it, Raghav? Are you fine with it? Aarti, you were saying anything? Aarti, you're asking some question between, I guess. Okay. All right. So there is a second way also, and the second way is to use annotations. So if you see the .hbm.xml file, now that .hbm.xml file has the mapping between the table name and the class name. Now if you can find a way to understand, or what do you say, if you find a way to to represent the information which is in the XML file in the class file itself, you can get rid of that .hbm.xml file. All right, and this hibernate.cfg file has some of the basic information. I mean, you can still have some config class and put all this information there, but even Java Persistence API has support for, I mean, one XML file, persistence.xml, which has all this information. So even though Hibernate.cfg is not supported from Java Persistence API perspective, you still have persistence.xml, which has the same kind of information. So the use of this XML file is not gone. I mean, it's still there in one way or the other. But all this .hbm.xml file, which were the major volume drivers, and where the multiple XML files could have existed, that XML file structure is gone. Okay, you can use annotations, you can get rid of it. All right. So yes, and again, I mean, rest everything is same. So now you have classes, you have database table, you have annotations which represent the mapping, you have persistence.xml which represents whatever you're using for hibernate.cfg file. So you have all this stuff, and apart from that, right? Apart from that, you also have like you had hibernate, like you had session factory here, and if you would have remembered, I had said earlier that the terminology for referring to classes which represent the database tables is entity. So all such classes are called as entities. So if you hear entity classes, you can be sure that they are referring to some form or some object in the database. All right. So you need some classes which deal with these entities. All right, and then execute some queries for you. Okay, those classes are entity manager classes. We'll just see here. Now this is a sample Hibernate application. Now we already saw about the using XML. So this package contained all the files regarding the XML way. So, and even this customer.html.xml and hibernate.cg.xml was used there. But these two, com.jpa and meta-in, it's using Java Persistence API implementation of Hibernate, and thereby it uses annotations. So you have, I mean, forget about Apple and implementation, that is something else. You have customer, which is entity class. Then you have entity manager util, which basically, gets you a reference of entity. I mean, how to actually relate it to the DB, because here you do not deal with session and session factory. Use entity manager factory. Okay, and then this is the main class which you have. All right. So let's go below and see. See, this is how you write. So this is the entity class. Here you import certain statements, and then you annotate it. So annotations denote the meta information which is associated with that particular class. So whenever it's an entity, you have to say add entity, but that is not required. If you just put add table, I think it takes care of it. But anyways, I mean, add entity, add table, then you have to put name of the table, name as customer. Then for every field, because the HBM file had the relationship between both of them, right? They had the relationship between the entity and they had a relationship between the table and the class, and every attribute inside class with every column inside the database table. And that is what we are also doing here. Okay, so you have this customer object. It represents a table. that table name is shown here, okay, and then you have all the related what do you say all the related definitions put below. So you have this ID field. Add ID means that it is a primary key, then with which particular column it is associated. So it is associated with cust underscore ID column. Similarly for others as well, this one is associated with F name column in customer table. This attribute is associated with age column in customer table. So that's how the entire association is. Now this is the persistence.xml. So if you see, it has same kind of information. It's not hibernate.cfg.xml file, but it has the same kind of information. So you specify the driver class name, you specify the connection URL, username, password, etc., etc. And it's a major driving XML in the way in which we use annotations, and whenever we are using annotations, that way is also the way in which JPA accesses, also recommends accessing details from the database. Okay, so Hibernate's way of using annotations follows JPA standards, in other words. Now let's go below. So we had entity manager util class. Now if you see this class, it's using persistence. This is our persistence.create entity manager factory, and you give name of the entity, name of the persistence unit. It is MySQL-DS. So what is a persistence unit? So here you define persistence units which are there. So this is, if you see this particular persistence.xml, this is one persistence unit. The persistence unit name is MySQL-DS. So the entire stuff is belonging to one persistence unit. So what this means is that you can have, like say an application, if I am writing an application, I can have, my application can be huge, right? It depends on my requirement. I can have one Oracle DB, and I can have 5 different databases. They are all Oracle, but with different username and password. So they're basically different databases. So in that case, I can have 5 different persistence units, and they all can be defined in the same XML file. And then later on, using different persistence unit names, we can get a reference of different entity manager factories. Okay. So once you get a reference of entity manager factory, you had this demo class. Okay. Hibernate demo test. Now here, if you see, what we're doing is entity manager util. This is the class which we wrote earlier. From here, using .get entity manager factory .create entity manager. So this first line is going to return you, and let me go a bit above. Don't get please bogged down by it by going up and down the slides. This is just for a reference. If you see here, it does create entity manager factory. So it returns you a reference of entity manager factory. Now once you have a reference of entity manager factory, you do .create entity manager. So there you are doing session factory, and then using configuration class, a new configuration .configure.build session factory, you're getting a reference of session factory. From session factory, you're doing sf.open session, and you're getting a session. That was the way in which you did the normal XML way. In annotations, you use entity manager factory. Alright, so you use persistence class, persistence.create entity manager factory to get a reference of entity manager factory. Once you get a reference of entity manager factory, you do create entity manager to get a reference of entity manager class. So entity manager class, once you get a reference, again using this, you can start the transaction. So you have here em.get transaction. So the transaction is you get the reference of transaction, and then you can start the transaction here using transaction.begin. Now once you do a transaction.begin, you can have your own stuff here. Customer, cust1 is equal to new customer, then you set the required parameters. You can have different customer object as well here, which is here. Then you do em.persist customer2, em.persist customer1. So this persist API is there on the entity manager, and you can save these details in the database. Now this detail is, once if it doesn't give you any error, it means it is saved. So you do a commit, and it actually commits it. It's saved for the session, but once you do a commit, it saves it for all the users who want to access that detail from the DB. And then do entity manager.close. So this reference is closed now. Alright. So this is the annotation way of accessing Hibernate. Are you guys clear with it, or do you have any questions? Are you guys fine with it or not? Not much. What about others? What about others? Did you understand? Yes, I can repeat. Not clear. Okay, so let me ask, what is not clear? Which portion is something which like did not strike with you? I just want to understand like what should I repeat more in order to make you understand it.
For me, it's a lot of new names at once, so I couldn't follow up with all the stuff.
Okay, okay, fine.
I mean, the flow of it, if you could just show the flow by writing or the architectural picture or something, then I don't know. That would be easy to follow, I think, because here not everything we can see.
Okay, okay, fine. Maybe the snapshot is small. I'll repeat it. Okay, thank you. So let me go here. So let me go to this. This is my application. So are you guys? Can you look at it? Is it? Are you able to make out? See, this is. I have put both the ways in one place itself. So let's see one by one, and again I'll use my word pad to explain you. But just to explain here, you have. I'll explain the persistence XML way. So you have persistence.xml. All right. So persistence.xml is a way. See, the annotations came later on. So earlier we had this XML way. So annotations when it came, it at the same time, the Java persistence API also came. So they advised doing things. They provided specification in a one way. So they said that the applications which use JPA should have persistence.xml. Now this persistence.xml did not have, one-to-one mappings. There is no persistence.xml in the way in which Hibernate was using it earlier, right? But what we saw is that persistence.xml has the same configuration, same information which is there in the hibernate.cfg.xml file. All right. So that's the reason. Hibernate when it provided implementation for the JPA. Whatever content was there for hibernate.cfg.xml, that content is moved here because persistent.xml you can say can be used instead of using hibernate.cfg.xml. So here what we are doing is we are defining all these all these high level database property stuff. So you have the driver class name, you have the URL, you have the username, you have the password, whatever information was there in the hibernate.cfg.xml file, that information is present here. Alright, and this is a persistence unit which is mentioned, mysql-ds. So this represents a database. But say my application is huge, I need 5 different databases. So I can copy paste it, or not copy paste it, I can create different persistence units with different names, and obviously the driver class might be same since it can be SQL, but the URL, username and password will change. Alright, so this is a persistent.xml which is required for the annotation way. Apart from that, we have the entity classes. These entity classes are nothing but the classes which are associated with the tables, they are called as entity classes. And how do we explain them? How do we say that in a non-XML way? Is to use annotations. So if you write something like this using add, it's like using annotations. These annotations represent some metadata about it, and the framework which is there, like say wherever you're using it, that reads the persistence framework, because it supports the Hibernate framework, because it supports annotations as well, right? So these elements, whatever is written here, like say add entity, add table, add ID. So Hibernate framework has a code to read these annotations, all right, and figure out like how the table and the corresponding class is related. So in the XML way, we are having the mapping defined in the hbm.xml file, but here it is not done. Here you define in the same class. Hibernate takes care of creating the mapping in its own classes. I mean, it's not exposed to you. It's done there itself. So whenever you have a class that is annotated, if it's entity class that is annotated with add entity, for the table which it is associated with, you say add table, then you give the name of the table with which it is associated with, then you define all the corresponding columns. Okay, so if the column name is ID, if the column name is first name, age, etc., that is defined, then you say add column, and then you give the name of the column in the DB to which it is associated with, and similarly it goes for other columns as well. So that's how the definition is there for customer table. Alright, now this is the only entity which I am explaining right now. Now if you go inside this one, this was the it was having the main class. Now coming back to entity manager util. So if you see what it does, this persistence class is also provided, and let's go back and see here. See javax.persistence.persistence. So this is something which Java provides as an interface. Okay, so Java persistence API, when it gave that specification, JPA, when it gave that specification, it gave a list of classes, and these classes are blank classes. I mean, to be very plain, in the sense that they are interfaces, they don't have any implementations. Okay, the implementation has to be provided by the actual provider which implements this interface, which implements this specification. So JPA, Java Persistence API, is a specification to say that this is a way in which the details have to be accessed. You have to use annotations, etc., for saying that this class belongs to a particular table, and then from the code, I mean the whichever is implementation provided, like say Hibernate or OpenJPA or any other such implementations, they can follow the similar way to get the details. So similarly, how to get the entity manager factory, that has been defined here. So entity manager factory, basically again it's a sort of session factory equivalent in the XML way world. So using this persistence class, you create entity manager factory, you give the persistence unit here mysql-ds, okay, and this lets you get all the necessary information from the DB. Sorry, not from the DB, from the XML file. Once you have this necessary information, let's go back to this main class here. Once you have all the necessary information, you do .create manager. So this .create manager is same like you are actually you're actually going and connecting to the DB. There is an actual connection object wrap inside. So this concept of entity manager is similar to that of session in Hibernate XML world. So once you have this entity manager EM, again there you're beginning the transaction, right? Session.begin transaction. Here you have to do here you have to first get the transaction. The transaction object as such, which is basically a object of type entity transaction. Then you have to begin the transaction, and then you have to commit the transaction. So once you commit it, it typically ends, and then in between you can have all the customer objects, the details you can save in the DB using em.persist. So in the old XML way, you are doing session.save. Here you are doing em.persist. And once it is done, there you are closing session.close. There you are calling session.close to close that session. To close this entity manager instance, you do em.close. This is how your entity manager factory, or say the annotation way of accessing Hibernate works. Alright. So let's draw a parallel as to how it exists. So see, you have session factory object in the XML way, all right, and then you have entity manager factory in annotation world, all right. So you have session object in case of doing it in XML way. You have entity manager if you want to use annotations, all right. And again, in both places you are having transactions. Those trans sorry this is those transactions are you have transactions in both the places. Again, the name of the class is different. There it is org.hibernate transaction, and here I think it is java is.transaction or something, but just for simplicity let's mention that much. Okay. So this is how the relationship is. So there in the XML way, you're getting you're using configuration class, right? New configuration.configure to get an instance of session factory, right? And then from the session factory you used to get session. From the session you used to get transaction, right? This is how your flow was in the case of XML way. In the case of annotation way, you have configuration. Sorry, not configuration. You have persistence. From persistence, you get the entity manager factory. Right. From entity manager factory, you have entity manager, and then from entity manager, you can get the transaction. So this is the annotation way of getting the details. Alright, now coming back to the XMLs which are there. So there you had .hbm, .xml files. This was with XML way. Here you do it in the entity classes. So basically there are classes which have add entity, which have add table name annotation at the top. Alright, so this is for that one. Hibernate in XML way you have hibernate.cfg.xml where database username, password, etc. is defined. In annotation way you have persistence.xml. So this is how the relationship is between both the parties, I mean the XML and uh, the annotation way. So guys, is it clear now? Guys, is it clear now? Okay. What about others? Is it clear? Okay, okay, thank you. So let's move ahead. Now again, I mean, I'll give you my project structure. So what I wanted to show you was that to run this hype, and how many of you are aware of Maven? Maven. What about others? Are you guys aware of Maven? Okay. The thing is that it's not part of the course structure which I have, so that's why it's not going into detail of it, but I think it's useful. So just to give an overview, I'll tell you what it is so that you can start using it, everyone. But anyways, for now, let's say if we have sample Hibernate and I do a right click, and this is where I've configured all the jars, all the necessary jars for Hibernate, right? So when you have this Hibernate annotations jar which is required for annotations, Hibernate commons annotation which is required for annotation, but other stuff like say Hibernate core, this is required for XML. Okay, Hibernate entity manager, this is required for annotations way. Hibernate JPA, this is required for annotations way. Alright, so these things are there. I have put all the jars here, the necessary jars, and there are some other peripheral jars. So what I mean is that, say, these Hibernate core jar, it internally uses, say, commons collections. It internally uses DOM 4G. So these jars are also required. So the way in which I proceeded, because just wanted to give you an overview. So, and since I had not dealt with Maven, so I did not want you to give that point of view here. So what I did was that I like, say, whatever API is required, I first imported, like say Hibernate Core, I downloaded and put it in my folder C colon jars. Now once that is done, I ran it. So you'll get errors. So you'll find that this error is because this class is not found. So again, I found those classes, put it here. So with Maven, this is where you can do. This is perfectly acceptable. But in Maven, what the thing is that there is one XML file, and this is a Maven project. So you define the XML file, you give all the necessary jars, and whatever is a peripheral jar, like say commons collections, you are not using it, but is getting used by Hibernate Core. It will download it. You don't have to specify it from your own side. So that is the use of Maven. You can and Maven again is from Apache, so you can go ahead on Apache Maven site, download the latest one. You don't have to do anything much. I think you just have to uh, things have changed here in Windows, I think. So once you set Maven, what you need to do is that you can download Maven. It's a zip file. You can unzip it and place it in one location in your PC. There's no further installation required, and then you can give your. I put Maven underscore home, but instead of Maven underscore home, you have to put M2. So that I think I have not put it here. That you can just define. So it is called as M2 underscore home, and it will be defined in the Maven site also. I just mention it, M2 underscore home. So in my workspace it is defined. So it is M2 underscore home. Alright. So you define M2 underscore home, you define M2. These two variables should point to wherever your Maven is there. So if you have put it in, say, C colon Maven slash, so till that place you need to give. Again, here also give till that same place. And in the path you need to add, don't remove everything, you just need to add an extra thing, which is for C colon, say, Maven slash bin. So you have to go till bin folder and put it here. So this much is required, and again, even if you don't do this much, you can work on it. The only thing is that if you do this, you can directly run the queries, etc. So this is one configuration which is required. Once that is done, what you can do is that in Eclipse you can go here. I think install new software is one. This is STS, it is a bit new, but in Eclipse you have this marketplace. So you can go there, you can just type for one plugin. The plugin name is M2E. So if you type this much, click on search, it will give you the options. There will be two M2E Eclipse things. Download both of them. So those plugins, once it comes, you can create Maven project. And I think STS by default, the Spring Test by default has support for Maven. But once you include that plugin and restart your Eclipse, you'll have support for Maven as well. So you can do a right click, go here, say new, and then do say project, and then if Maven is supported, it will show you an option of Maven as well, like say here. So Maven, and then you can select a Maven project, move forward. All right. So if you select a Maven project, the idea is, something like this. Let me show you. So coming back to the PDF which I have, so this number of jars which was there that I've already discussed, I put a snapshot here as well. Apart from that, you can use this Maven tool. The Maven tool requires pom.xml, so it has this particular kind of XML structure. All right. So the project, and then there you define all the dependencies, like what jars you need. I need MySQL jar, and what is the case with that? What is the dependency? So you can define all this stuff here. You don't need to specifically download the jars yourself and do it. Maven basically, once you download it, and this particular location which is there, C colon Maven. There you have inside I think bin, or inside conf folder you have settings.xml. That settings.xml has a definition of everything. It has one repository as well, that this is where it looks for. So I think it looks on the normal Maven site itself. There you can find all these jars. So you need not specify anything properly. Like uniquely. But I just wanted to give a reference. So I told that there is a file settings.xml, right? And apart from that, there will be option of local repository. All right. Let me show you. See, this is Apache Maven structure. So this is conf folder. Inside this, you have this settings.xml. Now this settings.xml has all the necessary information. You did not modify it. It also has, say, this is how the repository etc. are also mentioned. It has one place, and this is actual repository is mentioned here. It has one place where you define I think see, local repository is defined. So here you can define the local repository, what it should be. If you do not define, the default is it in your user.home folder, it creates this .m2, and inside that you have this repository. So this is whatever jar it downloads, it puts in this particular location. All right. So this is what is there for Maven. It is not required as per the course structure, but if you have it, it will be easier for you to execute all this query, all these projects. And even if you find something on internet, you'll find many stuff which uses Maven, so it will be easier for you to follow from that perspective. All right. So that's why I gave you this overview in Maven. Work on it. If you have any issues using it, get back to me. All right, and I'll help you with that. So this is what was there for today's class, the Hibernate Introduction. I hope the introduction should have worked for you. I will send you the videos as well. Please work on the assignment. The assignment is for today's classes that you create a user table, and I want you to write a Hibernate application using both XML and annotation way to insert data in this table. Nothing else. So this is the assignment which is there, and that's it. Are you guys comfortable that you will be able to do this assignment? Are you guys comfortable?
I have a question.
Yeah.
Do the XML way, can we do everything with the Hibernate without using any SQL or the creating elements?
I was not able to get you, Aarti. Can you repeat once? Like, what exactly is the question?
No, I was saying, does Hibernate take care of completely creating the database and everything, or do we still need SQL?
Hibernate, like say these DDL statements. you can there is one property, I have not mentioned it there and I don't remember it off my, like, on top of my mind. There is one property, generate SQL, something of that sort. There, I mean, if you associate, since you have associated with a particular schema, if you give that thing, then it generates all these DDL statements also for you and executes once you run the application. So that is there, but my recommendation would be that let's keep that detail part separate. I mean, it would be better if we can write it ourselves, because typically in production environment, I mean, you don't, like, drop your database tables and create it again. So although Hibernate provides it, it's basically used only in developed environments most. So if you want, you can search for that. And if you do not get it, I can also find it for you and tell it. But there is one property which you need to provide. I mean, it can create all the details for you and execute it at the start of your application or whenever you run the main method. So I mean, that is well supported. I mean, it's out there. It does the work.
So does it do for both the XML and annotation,
Correct.
both the
Yes,
cases?
yes, yes. It does for both.
Okay, thank you.
Okay. Any? I mean, are you guys comfortable? Can you work on the assignment? I need yes, no, maybe, sure. Okay. Guys, in next class, the first thing which we are going to do is discuss on the assignment, and I'm going to ask you one by one. All right. And if you have not worked on it, I mean, we'll stop there and there, and we'll do the assignment in the class itself. In the sense that I'll be there. I'll ask you to work on it, because without, every time we read a new topic, you go ahead and even if you understand it and you do not work on it, I mean, you're not able to understand the details. So please work on the assignments. If you have any issues, please get back to me. So that's it which I have for today. I'll be around for some more time saving all these videos